All right, so working our way through chapter 3. Getting into 3-4 here, again, still dealing with parallel lines. But as far as this proof goes, so we're given that R is parallel to T and S is parallel to T. So that's where we're going to start. So 1, R parallel to T, reason given. Number 2. Well, what does that mean? Well, it means that angle 1 is going to be congruent to angle 2 by definition. And that's kind of going to all encapsulate or include the fact that these are both going to be right angles by definition there. Perpendicular means right angles. We also know that right angles are congruent. So by definition, both of that kind of gets fit in there. So then 3, we can say that R is parallel to S by postulates. 3-2. Because 3-1 is saying that, hey, if they're parallel, then corresponding angles are congruent. Here we're saying, hey, they're going to be parallel because corresponding angles are congruent. So if the corresponding angles are congruent, then we know they're parallel. So we have Theorem 312, the triangle angle sum theorem, which says that the sum of the measures of the angles of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C is going to be 180. So our 3 angles will all be congruent. Now, if we have this triangle, and let's say I take and I rip off that side and I rip off this side. So I have my 3 pieces of the triangle. Well, if I take this side and put it up here, and I take this side and put it right in there, of course now I bumped it, but what does that form? Well, forms a straight line. So here's a visual representation of why that works. So if we take all those corners and put them together, it's going to make a straight line. So they have to be 180. All right. Another way that we can prove that. Well, I guess I still need this here. Well, how we're going to do that is this. Is our first step is we are given triangle A, B, C. Next, we're going to say draw DE, which appears to be a segment, such that DE is parallel to AC. This is going to be by construction. So we want to specifically have it this way. And that's going to make this proof work out. Try to go up just a little bit more so you can see this. So 3 then, we're going to say that angle A is going to be congruent to angle 1, and that angle C is going to be congruent to angle 2. So can put multiple things together, and reason why is they're alternate interior angles. So we know if these lines are parallel, alternate interior angles are congruent. So this is going to be by alt interior angles. Okay. So knowing that, well, we can say that angle 1, the measure, I should say the measure, of angle 1 plus the measure of angle B plus the measure of angle 2 has to be 180 degrees by the protractor postulate, which I believe was 1/6. Pretty sure that's what it was. There, it's 1/8. We'll just leave it as the protractor postulate. Well, what do we know already? Well, we know A is what 1 is, and we know C is what 2 is. So we can say the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 by substitution. So 1 is congruent to A, so A gets subbed in for 1. C is congruent to 2, so C gets subbed in for 2, so now we have it, which is what we're trying to show. Now, to find the values of x and y. So we have a couple things going on. First off, we're going to focus in on this here triangle. We have 65, 39, and x. Well, we know that all three have to be 180. So 39 plus 65 plus x is equal to 180. And that's by that theorem 312. So we know that if we add the three interior angles together, we equal 180. So 39 and 65 would make 74, 104. So if I subtract 104 over, x would end up being 76 degrees. So 76 degrees. Now, to find y, we know that x and y make a straight angle here. So if x is 76, y would have to be 104. Because 104 and 76 make 180. Now, for the fun of it, we could find z. Well, if we know this is 104, and that's 121, z plus 104 plus 21 would have to equal 180 again. So z plus, this would make 125 equals 180. So z, if we subtract 125 from 180, would end up being 35. No, 55. 55, wow. And again, I cut all that off, and I'm sorry. So, interior angles of a triangle add together to be 180. You can use that to solve problems. Now, some other things we can think about here, and I'm going to zoom in a little bit, is we can classify triangles by their angles. So if all three are the same, it's called equal angular. If all the angles are acute, it's an acute. One of them's right, it's a right angle. One of them's obtuse, an obtuse angle. We can also do it by their sides. So if we have all three sides congruent, it's an equilateral triangle. If we have two sides congruent, it's isosceles. And if none of them are congruent, then it's scalene. So, classify this triangle. Well, first off, angle-wise, all of these are less than 90. So it's going to be acute. But if you also notice, we have a tick mark here, no tick mark on the bottom, which makes it isosceles. So two ways to identify it, one by the angles, one by its sides. So this would be an acute isosceles triangle. Now, with triangles, an exterior angle can be formed by the side and extension of the adjacent side. And so this will work for any polygon, including triangles here. So we're going to focus on triangles at the moment. But this would be your exterior angle, angle D. Then we have our remote interior angles, which are the two non-adjacent angles of each exterior angle. So if D's our exterior angle, that would make angle A and angle C the remote interior angles. So just think remote interior angles are the two that are away from the exterior angle. So if D is our exterior angle, A and C are the two remote interior angles. Now, what does that mean? Well, we have a theorem. Theorem 313, triangle exterior angle theorem. So what it says is the measure of each exterior angle will equal the sum of the measures of the two remote interior angles. So on that last one, D is going to equal A and C put together. And that's going to allow us to find some angles. So if I zoom in again. So angle 1 is the exterior angle. 40 and 30 are the two remote interior angles. So if I add those two together, the measure of angle 1 should be 70 degrees. Now, that can work if you know one of the interior, but the exterior, and the one other exterior or interior. Well, then we would have 70 plus the measure of angle 2 would equal 113. So now you have your equation. You solve it by subtracting 70, so the measure of angle 2 would have to equal 43 degrees. So, things you can do when solving these problems. So, I guess I should have stayed zoomed in. So, what's wrong with this figure? Well, you're going, well, for one, we're missing the other interior angle. But that Theorem 313 says that both B and C together would have to add up to be 180. Well, if this one's already 85, we're already bigger than what our total is supposed to be, and we can't have a negative angle. So what's wrong with the figure? Is angle C is bigger than our exterior angle. So we can't have an interior angle be bigger than what the exterior angle is. At least the remote interior angle. So that's it for this lesson. Let me know if you have any questions, comments, concerns. You can pan me, email me, send me a message on Google Classroom. Otherwise, we'll talk to you later.